One of the principal things you will be doing with Gibbs free energy is predicting whether a reaction is spontaneous. And delta G of reaction under standard state conditions, anytime that that value is negative, then that reaction is spontaneous. And so there are two ways to do this. If you're lucky, the simple way is if you have Gibbs free energies. You know the standard Gibbs free energy of formation for a given compound. So given a balanced chemical reaction and a table with Gibbs free energies, you can actually calculate this very simply from our standard behavior, where delta G of reaction will equal the sum of the delta G's of formation of the products minus the sum of the delta G's of formation of the reactants. We have that information in a table. It's actually relatively straightforward, just like delta G and delta S. So here we have our, again, we scale with stoichiometry, making sure to take into account. So here we have a nice little table. We have a nice little table that actually has these delta G values all laid out for us. So it should be straightforward for us to take care of that. So products minus reactants. Our goal is to see, is this reaction spontaneous? So products minus reactants. So we'll start with the CO2, negative 394.4 kilojoules for the CO2. Products minus reactants, the sum of the products, there's two waters, 2 times negative 237.2 kilojoules for the water. All of that minus the methane, which is negative 50.8 kilojoules per mole. Plus the oxygen. Oxygen has a delta G of 0 times 2, which makes it simple. The sum of the products is negative 868 kilojoules. The sum of the starting materials is 50.8, negative 58 kilojoules. Products minus reactants gives us a value of 818 kilojoules, negative 818 kilojoules. So the delta G of this reaction will equal negative 818 kilojoules. That's the simplistic case, products minus reactants, to give us our desired answer.